We're going to solve exponential equations using logarithms now. So in order to do that, let's take a couple quick examples from yesterday. So 5 to the x equals 5 squared to the 2x. So x equals, well, I can simplify the right side to be 5 to the 4x. So x equals 4x, and the only way that that happens is when x equals 0. So in the first problem, x equals 0. 6 to the 4x equals, well, 216 is the same thing as 6 cubed. So that's going to equal 6 cubed. So I have 4x equals 3, because when the bases are the same, then I can set the exponents equal to each other. So x equals 3/4. Now in the third problem, I have 5 to the x equals 49. Now, in every single problem that we've done on the notes and on worksheets so far, we've been able to get this number to be the exact same as that number. But 5 squared equals 25. 5 to the third equals 125. And 49 is somewhere in there. So the best I know is that x is somewhere between 2 and 3. And it's actually not equal to. So x is somewhere between 2 and 3. But that's not really getting me exactly what I need in order to get the right answer right now. And it's not like I can just magically in my brain come up with whatever x would be as some kind of fraction or something. And x actually is not a nice enough number where I can write it as a fraction. So we have to learn something new in order to be able to do this. So we're going to learn about logarithms. Logarithms are actually just another way of writing exponents. So one thing that we'll talk about a lot is that logs and exponents are inverse functions. So they're actually ways of undoing each other. So let's take a look. A to the b equals c is the same thing as saying log base a of c equals b. So since they're inverse functions, basically what I can do is if I do a log base a of both sides, this ends up kind of looking like this. And then since they're inverse functions, real quick primer on inverse functions. If we have, for example, x cubed equals 8, the way that we would solve this equation is by taking a cubed root of both sides. So x cubed, so like the cubed function and the cube root function undo each other. That's what an inverse function is. So these are undoing each other basically. And we would get x equals 2 in this little case. Well, log base a of a to the b, these basically undo each other. And I'm left with b. So b is equal to log base a of c. And that's kind of what's going on here. So these aren't equivalent in terms of them being the exact same thing, but these two things are true at the same time. So they're true at the same time. So what that means is if I have a to the b equals c, that means log base a of c equals b. And so I can just kind of rewrite these things in that way. Likewise, if I see a log function, I can rewrite this as a to the b equals c. So that works in a lot of different ways. So now let's go back to this problem. 5 to the x equals 49. In order to be able to solve this, I don't know what that is. But what I can do is I can do a log base 5 of both sides. So if I do log base 5 of both sides, the log base 5 of 5 to the x, that basically goes away and I end up with x. Now on the right side, I have log base 5 of 49. And that is my final answer. So x equals log base 5 of 49. I would just leave it like this because I can't simplify this at all. Log base 5 of 49, in order to get that on the calculator, we're going to go to the math button. And in the first column with math, you can kind of go near the bottom. And on a lot of your calculators, it will say log base. So if you go to log base, it will actually show up. And in math print, it will look exactly like what we want it to look like. So log base 5, and then you hit the right arrow, and then 49. So log base 5 of 49 gets me this number. Now notice it's between 2 and 3, which is what we predicted it would be. Now, just to make sure that this actually makes sense, if I do 5 to this number, so 5, 5, and then the caret to this number, 5 to the answer, that should end up getting me 49 because these are inverse operations, and it does. If I have a log function and I'm using a calculator that doesn't have that log base, I can still do the problem, but I'm going to have to use what's called the change of base formula. So the change of base formula just basically says I do log of any base. Now, if I just type log into the calculator with the log button that's on my screen, that actually represents log base 10. But if I do log of 49 divided by log of 5, then I'm going to end up getting this 2.418 number. Okay, I can also do that with natural log. So natural log of 49 divided by natural log of 5 will get me the same thing. So if I don't have that log base as my calculator, as something on my calculator, I can actually still get the right answer. So let's just do a little practice converting. Convert from exponential to log and convert from log to exponential. We're not asking to solve or anything, we're just converting. So if I have 5 to the 3x equals 2, in order to get rid of the base of the exponent of 5, I would do a log base 5 of both sides. So the right side is going to become log base 5 of 2. And then, I'm sorry, that's the right side. And then the left side, if I do log base 5 of this side, that's going to essentially undo the 5 to the power, and I'm going to be left with 3x. So 3x equals log base 5 of 2 is going to be that. Now, if I convert this from log form to exponential form, I can do q to both sides, and that essentially undoes the log base q. So what's happening is I'm going to end up with 7p on the left side and q to the 8 on the right side. Let's solve this one. 5 and 4 do not, there's no way I can get a like base there. So that means I'm just going to do log base 4 of both sides. So log base 4 of 5 is equal to x. Because if I do a log base 4 to the right side, that undoes the 4 to the power, and then I'm just going to be left with x on the right side. So x equals log base 4 of 5. Let's take a look at log base 4 of 5. So I'm going to go to log base 4 of 5, and that gets me 1.16096 or something like that. Just a reminder, if you don't have this on your calculator, you can do log of the big number divided by log of the base, and you will end up getting the correct answer, so you don't have to worry about that. Now, real quick, let's just make sure that if I do 4 to the 5th power, or 4, I'm sorry, 4 to the whatever this answer is power, then I get 5. And that appears to be true. Evaluate. So log base 2 of 8, well, I can actually figure this stuff out because 8 I can rewrite as 2 to the 3rd. So log base 2 of 2, well, that's 3. That has to be 3 because log base 2 of 2, those undo each other. And so this ends up being 3. Likewise, if I was thinking about it in exponential form, it would be 2 to the something power equals 8. And I know that that something has to be 3. Likewise, this has to be 2 because in this problem, we have 11 to something power equals 121, and I know that would be 2. The other thing I can know is that if I have log base 11 of 121, I can rewrite 121 as 11 squared. So the log base 11 of 11, that basically cancels each other out because they're inverse functions, and then I'm just left with 2. Okay, log base 7 of 1, log base anything of 1 is always 0. And that's because 7 to the something equals 1. That something has to be 0. The other way I can think about it, log base 7 of 7 to the 0 power, because 1 is the same thing as 7 to the 0 power, and then I can convert this log base 7 of 7, that ends up canceling each other out essentially, and I end up with 0. Log base 25 of 125, well, 25 to the something power equals 125. That something has to be 3 halves, because 25 is the same thing as 5 squared. So 5 squared to the something equals 5 to the third, because 125 is the same thing as 5 to the third. So that means that I have to have 3 halves in this box in order to make both exponents equal. So this is 3 halves. Log base 27 of 1/3, 27 to the something power equals 1/3. I can rewrite 27 as 3 to the third. So 3 to the third times something equals, well, 1/3 is 3 to the negative 1. So I need to fill this box with something that's going to make this work. So 3 times something equals negative 1. That something has to be negative 1/3, because 3 times negative 1/3 equals negative 1. Log base 1/4 of 64, 1/4 to the something equals 64. Now 64 is 4 cubed. So I'm going to rewrite 1/4 as 4 to the negative 1 to make my life a little bit easier in doing this problem. So that means that this number has to be negative 3, because negative 1 times negative 3 ends up equaling 3. So the final answer for that one is negative 3. Now we're going to solve these two problems really fast. 3 equals 7 to the 4x minus 5. So solve means actually get x all by itself. So I have to get rid of this 7 because it has the exponent. So I'm going to do log base 7 of both sides. So log base 7 of 3 equals 4x minus 5. Now I'm going to add 5 to both sides. So I have log base 7 of 3 plus 5 equals 4x. Then I divide by 4. So x equals 5 plus log base 7 of 3 all over 4. And I just use the commutative property of addition. Also, sometimes it's confusing to write log base 7 of 3 plus 5. You may want to put this in parentheses or the whole log in parentheses so people don't get confused and think that you have log of base 7 of 8 and thinking that this 3 plus 5 is actually something you can add together, because you can't add those together. So that's why I wrote it like this, so I didn't have to put the parentheses. Finally, I'm going to add 9 to both sides in this equation. So I have 19 equals 6 to the 4x minus 5. I'm going to do log base 6 of both sides. So log base 6 of 19 equals 4x minus 5. I'm going to add 5 to both sides and divide by 4. So x equals 5 plus log base 6 of 19 over 4. I'm just going to practice typing the last two answers into the calculator just to make sure that we know what we're doing. So 5 plus, I'm going to hit the math button and go to log base. So log base 7 of 3 And then I have to divide that whole thing by 4. So I can do this in a variety of different ways. I can hit enter and then divide it by 4. Or I could put the whole thing in parentheses. So 5 plus log base 7 of 3. And then I have to make sure that I end the parentheses or else it's not going to work. Then I divide that by 4 and I get the 1.391 approximated answer. Now, a lot of these problems won't be calculator problems on the test. You'll just leave them as 5 plus log base 7 of 3 divided by 4. But just in case we want to know how to do something like this in the calculator, or there is a calculator question that I might have to do something like this, I want to make sure I know how to do it. What if my calculator doesn't have the log base? Well, I can do 5 plus log of 3 divided by log of 7. And then I'd get that 5.56 thing, and then I can divide it by 4. And likewise, I can use big parentheses to go around that whole thing and divide it by 4 if I wanted to do it all in one line. It would be very similar for the other problems, so I'll just do that real quick. I'll do it all in one line. So the last problem was 5 plus log base 6 of 16, and then I'm going to end the parentheses and divide that by 4. And my approximated answer for the last problem would be about 1.637.